Welcome Physics 195. We are group 127. If you like this video, give us a thumbs up, subscribe to this channel. So to get into the question, two spheres of 1 kilogram, 2 kilograms are connected by a 1 meter long rigid massless rod. The rod is rotating clockwise about its center of mass at 20 revolutions per minute. What net torque will bring the spheres to halt in 5 seconds? So what this question is asking us is to find torque. And torque is equal to inertia times angular acceleration, or angular velocity. So those are the things we're going to have to find. So that's the first thing we're going to find is our angular velocity. And that's going to be I'm going to consider that our step 1 of the problem. And the equation for that is final initial times time, right there. So do we have these unknowns? Well, they're given to us in the equation. Right, our final is right here, our 20 revolutions per minute. Our time, 5 seconds, and this is 0. So there we go. We have everything but this, but our angular velocity. So we plug those numbers in. We're going to put 20, but this is revolutions per minute. We need this answer to be in SI units. So we need to convert this into radians per second. So from revolutions to radians, if we remember, it's 2 pi. And from minutes to seconds, we're going to divide it by 60. So there we go. Equals 0 plus our angular velocity times 5. And that gives us an answer of 0.419. Bang. So we have half of our torque figured out. Now we've got to find inertia. Well, to find inertia, you need to know your center of mass. So that's what we're going to look for second. So that's going to be our step 2. Now, the equation for center of mass is going to be x1 times m1 plus x2 times m2 all over m1 plus m2. So what are our m1s and our m2s? Well, here's our rod. And we need to figure out where's our starting position in this rod. So I'm going to say this is our 0, and this is our 1 meter. Now we have to figure out where our masses are. So this is going to be our 1 kilogram, and this is going to be our 2 kilograms. We need to decide those reference points for this problem. It's easiest if you choose one side to be a 0 and one side to be the end, or the 1 meter. So plugging in, x1, 0, times m1 is 1, plus x2 is 1, times m2 is 2, all over 1 plus 2 gives us 2/3. So our center of mass is 2/3. There we go. So we have half of our inertia to find torque. Now we're going to move on to find our inertia in our step 3. So the equation for inertia is as follows. It's going to be m1 times our center of mass squared plus our mass 2 times our center, times x2 minus our center of mass. And all that is going to be squared. Well, we have all those values, so we're going to plug those in. Our m1, we already know is 1. Our x2, our center of mass, we know is 2/3, and that value is squared. Plus our m2, mass 2 is 2, times our x2, just like we did here. Our x2 we said was 2. Our x2 was 1, my bad. Minus our center of mass, 2/3 again. All that squared. And plugging that into the calculator, that gives us 0.667 kilograms per meter squared. Keep units consistent. Oops, I forgot units on these other ones. If you're curious, this is going to be, this one right here is radians per second squared. And right here, center of mass is just meters, because it gives us the distance of where the center of mass is. So now now that we have our inertia and we have our angular velocity over here, torque is just equal to our inertia times our angular velocity, and that's just equal to inertia 0.667 times 0.419, and that gives us a grand number of 0.279 Newton meters. And there you have it. There's our answer. Hope you enjoyed the video. Hope it made sense. Have a good day.